Our next task is to write a polynomial function with the following zeros. So we're going to take the zeros, and from the zeros we'll build the factors. So one of our zeros is 3. So we set the equation x equals 3. The other zero is x equals -1, and the third zero is x equals 2. Taking each of these zeros and actually setting them equal to 0, we have x minus 3 equals 0. We'll have x plus 1 equals 0. And subtracting 2 from both sides, we'll have x minus 2 equals 0. These are our factors. So now we'll put them into an equation. F of x is equal to x minus 3 times x plus 1 times x minus 2. So we started with the zeros. We use the zeros to build the factors, and now we're going to use the factors to build the polynomial. So we will multiply the first two binomials, and that will give us x squared minus 2x minus 3. Take your time foiling that out, but when you get it done, when you're done distributing or using the FOIL method, you should get x squared minus 2x minus 3. And then just time and space, I'm going a little quicker here. All right, now we'll distribute. We have to distribute the x squared to the x and the x minus 2, and that'll give us x to the third minus 2x squared. Distribute the negative 2x minus 2x squared again, and plus 4x, and then we'll distribute the negative 3 minus 3x plus 6, and our final polynomial function, we can clean it up just by combining all of our like terms, and we get a polynomial function that has the zeros as indicated. If you want to check it, go out to Desmos, type in the function that we just created, and you should see that it has zeros at 3 and 2 and -1. A 0, a 0, a 0, and when you graph, you should see your function do something like that on Desmos. All right, great. Now we're going to take a look at the next example. This time, our zeros are a little bit different. Our zeros, well, one of our zeros is 0, and the other one is a fraction. We still follow the same steps. We have x equals 0, x equals 5, and x equals 1/2. All right, so when we build our function, because we have x equals 0, one of our factors is actually x. That comes from x equals 0, our 0 factor, or 0 of 0. Then we have to subtract the 5 from both sides, so we get x minus 5 equals 0. So there's another factor. And then to get the third factor, we're going to start by multiplying both sides by 2, gives us 2x equals 1, and then we'll subtract 1 from both sides, and we get 2x minus 1 equals 0. So there's our third factor. So we will start once again by multiplying the first two parentheses, giving us x squared minus 5x, and then we'll multiply that by 2x minus 1 and combine any like terms as needed. So 2x squared times 2x gives us 2x to the third. X squared times -1 is -x squared. Negative 5 times positive 2 is negative 10x squared, and negative 5 times negative 1 is positive 5x. Combining our like terms, we have 2x to the third minus 11x squared plus 5x, and that's our function. Once again, if you want to check it, go out to Desmos, type in that function, and you should see a graph that has an intercept at 0, an intercept at 1/2, so 0, 1/2, and then an intercept way out here at 5, and the curve once again is going to do something to that effect. All right, next one. Next one, come on. All right, this time we have an imaginary root. Imaginary roots travel in conjugates, so you won't have the positive imaginary number without also having the negative imaginary number. So along with those roots, we're also going to have the negative 3i, or the conjugate of 3i. All right, so once again, we'll set up our zeros. So x equals 3i, x equals 2, and x equals negative 3i. Then, setting each of those equal to 0 will give us our factors. And then we can build our polynomial using those factors. Now I'm going to put the conjugates first. When I look at that, it looks like the difference of squares. Those are factors of the difference of squares. So if you want to take your time and FOIL it, that's just fine, but I know we're going to end up with x squared minus 9i squared. And we know that I squared is also known as negative 1, and so we end up with x squared plus 9 for the first factor, and then of course the second factor, x minus 2, we're going to carry that along in every step, and then finally distribute in our last step to get our final function. All right, distributing, we get x squared minus, how about x to the third minus 2x squared, distributing the x squared. Now we'll distribute the 9, that's plus 9x minus 18, and there you have it. There's your function with those 3 zeros. Last example has a irrational root, or an irrational zero. Once again, the irrationals travel in conjugate pairs. So if we know that if we are given a root of 1 plus the square root of x, 1 minus the square root of 2, not a square root of x, but a square root of 2, they will travel in conjugate pairs. So if we've got 1 plus the square root of 2, we also have 1 minus the square root of 2. And that is because in order to get a irrational, you need this quadratic formula, and the quadratic formula always includes the positive and the negative, just by its nature. All right, so let's go ahead and set up our factors. We have x equals 1 plus the square root of 2, x equals 4, x equals negative 1, and x equals 1 minus the square root of 2. All right, I'm going to switch colors here for the solving so you can see what's happening. All right, so on the first 0. We're going to subtract the 1 and the root 2 from both sides. And we get 0 and x minus 1 minus the square root of 2. We'll subtract the 4 from both sides, and we get x minus 4 equals 0. Then we'll add the 1 to both sides, and we have x plus 1 equals 0. And then again, we'll subtract the 1 and add the root 2 to both sides. And we have x minus 1 plus root 2 equals 0. And there are all of our factors. Now our conjugate pairs, we're going to write those side by side because we'll multiply those first. And then we'll have our x minus 1 and our x plus 1. Just to kind of simplify things and make things go a little bit smoother, we'll multiply the conjugate pairs, and then we'll multiply the two regular old binomials, and then take those two results and multiply them together. All right, first thing we're going to do is distribute the x, and that will give us x squared, then minus x, and then plus x root 2. On to the negative 1. Distribute the negative 1. We have minus x plus 1 minus root 2. And then we'll distribute the negative square root of 2. That gives us minus x times the square root of 2 plus the square root of 2. And then minus root 2 times root 2 is just plain old 2. Okay, when we look at all of those terms and we start combining our like terms, you will notice that we have a positive x root 2 and a negative x root 2, and they cancel out. We've also got a negative square root of 2 and a positive square root of 2 that cancel each other out. And so the only thing we're left with on the left there is x squared. We can combine our x's, minus 2x, and then we have a constant of positive 1 and negative 2, so that combines to give us negative 1. All right, so we still have to multiply the x minus 4 times the x plus 1, and we'll just take that right down here, and FOILing that out, we'll end up with x squared minus 3x minus 4. I got that middle term just in my head by multiplying my outers and my inners and combining them. We have one last step to multiply this out, and that is to distribute to multiply these two trinomials, and we do that, again, distribute each of the three terms in the first parentheses to each of the three terms in the second. So that will leave us with x to the fourth minus 3x to the third minus 4x squared. Distribute the negative 2. So minus 2x to the third plus 6x squared plus 8x. And then distribute the negative 1. So we have minus x squared plus 3x plus 4. And I'm going to just double check to make sure I haven't made any exponent errors or sign errors or multiplication errors. And if I've made any, I don't see them, but I'm sure you'll point them out. All right, now we'll combine all of our like terms. That's a third power there. All right, so we have x to the fourth. That's our only x to the fourth term. Our x to the third terms, you've got negative 3 x to the third and negative 2x to the third for negative 5x to the third And now we need our squared terms. You've got negative 4x squared, positive 6x squared, and negative 1x squared. And that those combine for a positive 1x squared, or just plus x squared. Onto the x terms, we have an 8x and a 3x. That gives us 11x. And then our only constant is 4. So there's your polynomial function with the given zeros. So the catch here is to make sure that if you have an imaginary zero or an irrational zero, you also include the conjugate. Thanks, and have a great rest of your day.